This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 63. Thierry Marchal and Marc Horner from Ansys share how users are leveraging Ansys simulation to fight COVID-19, along with news and events in the Ansys world. Hi there, I'm Eric Miller, one of the three owners of PADT and your host for these podcasts. Here we are, mid-May, and a little bit of an update on PADT's status. Really no change. We've moved, as we mentioned before on the podcast, about 8% of our employees to work from home. And our manufacturing facilities and IT team have been working modified schedules to keep essential things going and minimizing the amount of people in the office at any given time. But everything's running smoothly and at pretty much 100%. Even occasionally one of our product development engineers needs to go in. At some point when you're designing things, you gotta build the hardware and test it. So they've been doing that at home as much as possible, but also going in the lab and getting things done. So they've been making their way in as well in a safe way. We've got procedures in place and logs and all the things. All of the states where we have offices, if you're not aware, we have offices in California, Texas, Utah, Colorado, and New Mexico, as well as people who work from home in some other states. But all those states are now pretty much easing their restrictions. California, especially Southern California, a little bit less so. But in general, they're easing things up. But everybody's still got to recommend if you can work from home, work from home. They say it different ways, but that's pretty much it. So we're going to stick with that. Our next part in this journey is planning our phased return. We're in no hurry to take any chances. We've all stayed healthy through this and hope to continue to do so. So we're planning it out just like we planned going home. And the other thing, the reality is it's getting really hot here in Phoenix, and we're all going to be inside for the next 6 months anyhow. So it's a little bit different for us as far as where everybody else wants to get out right now. As part of that planning, we're using what the Ansys community is uncovering with simulation, which is the topic of today's episode. Is interview. And we look forward to sharing that with you in a few minutes. Before that, I want to mention that we are at 19,632 downloads as of the morning of May 17th when I'm recording this. And we're almost to 20,000. That's pretty impressive. People that have different listens. I also want to take a second to recognize the person behind getting these podcasts out on time. I mention him every once in a while in passing, but I was looking at some schedule stuff and realized how much he does to make sure that these things not only just happen when they're supposed to happen, because I'll forget if he doesn't help me, but also keeping the topics interesting. And that's Trevor Rubinoff. He's the person that does the emails and does the phone calls. He's kind of the producer of this podcast and needs everybody give him a virtual round of applause. He's keeping all the pieces moving. He also does all of our webinars, the blog stuff, case studies, articles, and interviews with industry media, anything that has to do with Ansys or Stratasys marketing. That's what Trevor does. He even redid the podcast logo. So we have a much more professional and a much more colorful logo for you to share with folks who want to check out the podcast. If you ever wonder how PADT does such a great job of communicating with the Ansys community, a lot of the credit goes to Trevor. So let's get into our interview and discussion here. There's a lot of videos floating around, not as many as I'd like, but there's quite a few floating around the community of Ansys being used to model all sorts of devices, masks, or just show how when someone sneezes, where does the stuff go? So we want to know more about it. We asked two experts on using Ansys in the medical field and also in other applications that are similar to join us to explain what people are doing with the Ansys simulation tools. And it's not just fluids. Thierry Marchal and Marc Horner are joining us, and let's hear what they have to say. Okay, I want to welcome everybody for a special interview. As we've been talking about on the podcast for quite some time, we're in the middle of the COVID-19 pandemic, and simulation is playing a role, as is a lot of technology, in helping understand and deal with this virus. And I've got two great people, longtime friends from the world of Ansys, employees at Ansys, Marc Horner and Thierry Marchal. And they've agreed to join us from various parts of the world to talk about how people are using simulation and Ansys simulation in particular to understand and combat this thing. So why don't we start with some introductions? Thierry, why don't you just introduce yourself and tell us how long you've been with Ansys, where you're working out of, and what your role is.
Yeah, sure. Well, I'm Thierry Marchal. I've been working for Ansys for nearly 30 years, so a very long time. I'm officially based in Belgium, close to Brussels, but according to my daughter, I'm more based in the airport, just like you. And well, I've got different functions. First, in marketing, I am the industry director for healthcare and sport, part of the corporate marketing activity. But as an extension of this activity, I've been recently nominated as the e-health expert to the European Commission. And also, I've been elected like the Secretary General of the Aviation Alliance, which is a worldwide alliance of medical device and pharma company interacting with government, US government, European government, but also regulator, in order to make sure that we define the right regulation and practice to use computer model for healthcare.
We're very excited about that, and we want to come back and talk about that someday because we want to be able to, PADT does medical device development, and being able to skip a lot of those testings and things is going to be, or get to the answer faster is going to be fantastic. And then Marc, why don't you let us know the same things about yourself?
Sure, thanks, Eric. Pleasure to be here. So I'm Marc Horner, and I started Ansys back in 2001. So I work out of our office in Evanston, Illinois, which is right outside Chicago. So I'm a principal engineer who also focuses on the healthcare industry, similar to Thierry. So looking after medical devices as well as pharmaceutical and biopharmaceutical applications. As part of my job, I also help to manage research partnerships with university groups. I also manage our regulatory partnership with the FDA. And then as part of our credibility activities that we're doing around modeling and simulation, I'm a very active member of the ASME VMV 40 Standards Subcommittee. In fact, right now I serve as the vice chair of that subcommittee. So we're really excited from the VMV 40 perspective to see what we can do to help bring credible use of modeling and simulation to healthcare.
Yeah. Very, very good. Very excited about that. Those activities. Yeah. So, but we're here to talk about a very specific pathogen. I know that the application of Ansys across healthcare is we could probably do 20 different podcasts on just the big picture of that, but in specifically about the COVID-19 and the SARS-CoV-2 virus and how it spreads and how we want to contain it. So I'm just curious if you can share, your guys' view, looking at what Ansys is doing, what customers are doing, what universities are doing with Ansys tools. How are they using Ansys to understand and combat this virus?
And maybe, Marc, I can start to give the 30,000 feet picture, and you can go deep into the technical side. In fact, we start that from the beginning. And I remember receiving an email from our CEO, Ajay, was asking me, okay, how can we help for that? We need to get rid of this coronavirus as quickly as possible. We are approaching that along two different angles, the prevention and the treatment over there. In terms of prevention, we are using this kind of modeling approach in order to see how this kind of airborne propagation can happen. Modeling the droplet for different people talking, not through the computer like what we are doing now, but when they are talking face to face, when they are exercising like the jogger, like the walker, and so on. Similarly, in terms of prevention, what is the role of the mask that you might be wearing, and especially for the medical staff, how can we get rid of the virus in the hospital? In terms of the treatment itself, there are two elements. When we have the patient lying in the hospital who needs some kind of respiratory assistance, what are the ventilators that we can develop faster? Is there a way to improve them? And for example, we've got the example of company who have developed a new ventilator in just 2 weeks by using simulation. The other point is for the future, and this is where we are acting very strongly right now, it's about the vaccine. We will be facing a first challenge in the humanity, in the sense that right now many people are trying to develop this vaccine on a lab scale. So possibly working with a 1 liter quantity. As soon as this vaccine will be approved, we need to suddenly increase the production in order to treat not millions of people, but billions of people. Right. This is the largest scale-up that ever happened in humanity. And so there will be a lot of challenge for that. But maybe, Marc, you've got some more specific details that you can give about some of the modeling that you have done with the North American team.
Mm-hmm. Sure, Thierry. Yeah, that was a great overview. Some of the additional work that we've been looking at is disinfection. So, for example, how do we disinfect the air or disinfect the surfaces that we come into contact with? One example is using the SPIOS technology that we have to model light as from a UV source and see how that light interacts with surfaces. How are we able to penetrate all the different surfaces that are in a room? And one of the engineers here was kind of joking that we need to come up with a UV light version of a Roomba. That can kind of run itself around an empty room and then disinfect that room and then know that it's safe to re-enter. But then in addition to the surfaces themselves, we have to be able to disinfect the air. So to ensure that the air that we breathe is safe within a hospital. So, looking at mounting UV systems within our HVAC systems so that we're sure that the air that gets circulated within the hospital or clinic, restaurant, mall, airport, et cetera, is free from bacteria or virus.
You bring up a really good point, which is, removing pathogens from the air using UV. Of course, being a more seasoned Ansys user, I immediately went to CFD for that. But we need to keep reminding ourselves that the simulation family at Ansys has grown so much, and the ability to model light accurately with the SPIOS product is critical for treating that. It also brings up another point. I wrote an article about, a year ago about we don't do moonshots anymore because we don't have great challenges. We can say we have a great challenge, but we really don't, right? So I think you talk about removing pathogens from the air, specifically COVID-19, but that'll be applicable in hospitals for all pathogens, right? So these developments in pharmaceutical and massive vaccination and will be applicable to so many different pathogens. So it's pretty cool.
Yes, and to some extent, this is not the start of the story. This is the reason why Ansys has been able to react so quickly. We've got several ongoing collaboration and partnership around the world. Very nice one with the University of Auckland in New Zealand, Oklahoma State University as well, where we were modeling the dispersion of influenza pathogen, and they are relatively close to the COVID. So it was a very nice start in order to say, okay, how can we refine that, customize that to the COVID-19? And certainly, what I do hope is that this is a major wake-up call for the entire industry and the government to realize that this kind of modeling approach can be very important for the future, because I'm afraid that this is not the last pandemic that we will be facing. We need to be ready for the next one, and simulation is proving to be extremely important in order to react quickly. Typically, you need between 10 and 15 years to design a new drug, a new vaccine. We cannot afford to wait for 10 years here.
Yeah, simulation is such an important part of that. Marc, what other tools are people using out there to model things in the Ansys suite?
So yeah, specifically to COVID, another set of simulations that we've been working on is with LS-DYNA. So Thierry mentioned the mask, and one avenue of simulation we use is Fluent, and look specifically at the air interaction between an air and particle interaction. What particles would be filtered by the mask, and what air would be filtered as we breathe out. And what are the pressure drops associated with that? So imagine a very rigid mask could be very hard to breathe, whereas something that's soft and it has higher permeability will allow air to go through more easily, but would then not filter particles. So we can look at Fluent or CFD tools to manage that. But now imagine we're breathing and maybe there's not a significant amount of deformation of a mask, but what if we cough? What does that mean in terms of even displacement of the mask, especially the made-at-home masks, and that we're looking at now, which could be much softer. So looking at one, how well does the standard respirator masks that we have fit on the face, as well as then the interaction when we cough and breathe, and doing fluid structure interaction simulations to say, how does that mass deform when we breathe, cough, or sneeze? So those are using LS-DYNA tools. So in that case, we're able to model, the explicit contact between the mask and the face, and then also capture, as we're breathing in and out, the fluid structure interaction, all within the LS-DYNA toolkit, which I think is really exciting. Another tool that we've been using is Ansys Motion. So being able to look at the rigid body interactions. So as we look at those those new ventilators that are coming out that are taking advantage of compressing an ambu bag, right? So in that case, you have a set of rigid parts that are interacting with this ambu bag, which is highly flexible. So we can look at the rigid part interaction like gears and struts, and et cetera, and how they induce motion and compression of that bag using purely Ansys Motion, and then representing the bag itself as maybe like a linear spring to capture the response of the bag. But Ansys Motion can give us some really interesting feedback on how those different rigid parts fit together to ultimately actuate the compression of the bag. And then the final thing I'll mention is on the additive side. So we've been using topology optimization and then additive manufacturing to help us understand how do we lightweight the frame that's used to hold that ventilator system, and then what can we do from an additive manufacturing side to print either custom parts, maybe the frame, although the frames do tend to be made out of plastic and not metal.
That's great. I mean, it's such a wide variety of applications out there. And I think also mention maybe in the long run using some of the controls, SCADE products to do, and some of the failure analysis products to understand and plot out the software for some of the respirator or the ventilators and things like that. I know that that's something else that people are looking at. So there's a lot of different places that the Ansys products can play a role. It's a very specific technical question that's been bothering me or wondering me. When you're modeling the particles of the virus itself in say Fluent, is that a special user routine, or are we just using normal particles and assigning some properties to them? How are we actually calculating the virus's movement in the flow?
So right now, we're modeling the particles that we exhale as a particle size distribution. So there's quite a bit of active research out there, as you can imagine, in regards to what is the typical particle size distribution just when we breathe in and breathe out, and then also when we cough or sneeze. So taking advantage of that, we can get a droplet size, if you will, from that. And so while we're not explicitly modeling the contents of those water droplets, which is partially coronavirus, we are modeling, we think, accurately the size of those particles. And then also, if I recall correctly, Thierry, some simulations are also including humidification factors. So what's the impact of humidity, et cetera, on potential evaporation of those particles? So some folks are looking at, as we move from, say, a very dry environment like where I am in the Chicago area, which some people call dry, to somewhere like India, where it's much more humid. What does that mean for evaporation of those particles and the evaporation rate? Because that feeds back into how long they're able to stay suspended in air.
That's a very important point. We do not model the virus. And I want to be very clear on that, because we were facing some problem with medical staff and epidemiologists telling us that, okay, we don't know anything about the virus contamination. And they are right. We are not epidemiologists. But what we know very well is what is the aerodynamics of this kind of droplet, depending on the size of the droplet, the evaporation of this droplet, just like Marc was mentioning, depending the temperature, the humidity level, and so on. And that's where we are helping quite a lot the epidemiologists. At the beginning, they were wondering what we were saying, and now they are very interested. A few of them have contacted us directly in order to see how we can join force and to help that. So we do not model the virus. And for example, along this line, there is still unknown whether very tiny droplet, something like 10 micrometers, can still convey the virus or not. So when we say that when you are jogging behind someone, you will penetrate a cloud of a tiny droplet, we don't say that you are going to a cloud of contaminated droplet. We just say that you are going to a cloud exhaled by people who are contaminated. Because today, the epidemiologist doesn't know whether this small droplet can contaminate some people or not. That means that it's better to be cautious. This is what simulation can teach people until the epidemiologist will be solving this kind of question. So that's why I want to insist on the fact that we do not model virus itself, we model the droplet.
Droplet itself. Good. That's good to know. And you brought up what I think is my favorite simulation, although I haven't been out running at a time when there's anybody else on the road, because we get up really early here in Phoenix to get outside. But the study that was done looking at, is it better to run side by side or one in front of the other as far as these droplet transmissions? Either of you want to comment on that simulation and what was found out?
Yeah, well, I was running that with Professor Verboeken from the University of Eindhoven in the Netherlands and KU Leuven in Belgium, and we were doing that relatively quickly. It was interesting. Verboeken is very well known for all his work for the Tour de France, for the cyclists, and so on. And he was approaching me to say, okay, what can I do in order to help COVID-19? And I was suggesting that we might be modeling the droplet from people running. We define a few situations where people were crossing each other, running side by side, or running one behind the other. And we were very surprised by the results. That's why we were publishing that very quickly. That's somewhat counterintuitive. This was my biggest surprise in this entire COVID-19 activity that we were doing, is that you need to watch your back. In the sense that when you are running, this is a little bit counterintuitive to see that the droplet, the contaminated droplet, will be behind you. At the same time, this is quite logical. You are running, you are moving on faster than the droplet that you have exhaled, and therefore they are behind you. On top of that, you need to introduce this kind of gravity. Large droplet, the most dangerous one, will be falling down. A small droplet can stay in the air, but we don't know whether they are contaminating people for a few meters. It was a very nice extension to social distancing, in the sense that clearly it had been agreed that for social distancing, 6 feet could be quite reasonable. But 6 feet when you are moving is much bigger than that. So that's why we were coming with this kind of recommendation of 10 feet, 20 feet when you are cycling. That doesn't mean that if you are running close to someone else, you will be contaminated immediately. That means that you might be taking a risk. Right. The risk is increased when you do that. Yeah, I don't really have a problem with anybody running behind me. I'm so slow, they pass me. But but
the point is, the point is though, is you. Well, go ahead.
That, if this guy is passing you, you have to make sure that he's not coming back in front of you too quickly. Otherwise, if this person is contaminated, that means that you can inhale the droplet that it's getting. But as you say, if you are very slow, that means that it will be a few meters in front of you.
It's a valid point, because that's generally what we do, right? Is the faster runner or cyclist will go around and then get in front of the other person. And what we should do is keep that spacing to the side, as well as until we've got this 10 to 20 feet distance. That's good input. There was another simulation I saw of a group of 3 gentlemen standing on a street corner sneezing on each other, I think. And I mean, anything to share from the study of that kind of interaction of sneeze? I think there was a sneezing in your elbow versus not, or covering your mouth, or anything to share from that. I think other than just kind of funny looking.
Yeah, no, I think that one, Eric. So two things to note. One, part of the reason we generated that video was this concept of social distancing. So, especially, adults, we learn that rules are there for a reason. We don't always know why those rules are there. But someone smart somewhere, hopefully, did a study and came up with that rule, and it seems to make sense, but we don't know why. But especially kids, my younger kids, it's hard to explain to them. When they cough or sneeze, they can't see where those droplets go when they leave their mouth. And the analogy I like to use is, if you go take your child to the zoo, if they see a dolphin, that dolphin spouts water through its blowhole. We can very clearly see, because the volume of water is so much greater and the droplets are so much larger, we can see where those water droplets go. But we can't see it when we cough or sneeze. So these videos really provide the kind of public service announcement, if you will, to visualize for folks, this is why social distancing needs to be adhered to. So if you're really wondering why, because every time I cough or sneeze, I can't see where the particles go. Thank goodness, right? Thank goodness. This helps to explain to people why they need to stay apart. And I think what's been really exciting with these is that I do a little bit of a survey, just asking neighbors, or if I go, I was at a pizza restaurant picking up a pizza to go recently, and I just asked, have you seen those videos? Oh yeah, I've seen the videos. Especially the running, jogging ones. So they are doing their job in terms of helping people to understand the importance of social distancing. And I think that the fact that they have been able to penetrate so deeply is great. The other thing I'll mention is you mentioned they look kind of funny. And so what we did in that case, the simulations themselves, you can imagine, look very generic and inside fluent. It's people in an open space, a very large box, and there's 3 body models there. It was really exciting to see, again, coming back to Spios and the VR experience tools, that we could skin those folks and put clothing on them, and then provide a background environment to provide more context, if you will, for the simulation. So I thought that was really exciting for me, just to take it up a notch and really show people in that social interaction, and they don't have to extrapolate as much. I think it comes as a bit of a double-edged sword, though, because then people may start to look at these as not being physics-based models, but instead something that's a CGI type model that would be developed for a movie. And I know they use modeling as part of what they do, but then the question becomes, where do we draw the line to make sure folks are aware that there's physics driving this type of simulation? So it brings up a new line of discussion when you start to look at these videos. But I was still really impressed with what we're able to do from the post-processing side and VR experience to really up the kind of.
I think it definitely spread more because of that, and this all kind of goes back to kind of that I don't know if you guys, I'm sure you guys remember the sneeze on the airplane that really went mainstream as a way to use simulation to explain to people how this stuff works. How long ago was that? That was
I'm not sure, ago. But
2014, 2015, something like that. But you see, Eric. What I wanted to add to what Marc was saying is that rather than imposing some rules from different governments around the world, and of course you will have people saying, okay, I don't want to follow the rule, I've got my own freedom. Here, with this kind of nice animation, we are not imposing any rules. We are educating people. We are showing them what's happening. And when you understand what's happening, nobody needs to impose the rules. Everybody will be following that because nobody wants to be contaminated. And that's why we've got a different organization around the world, governmental organizations from US, from Canada, from Australia, from UK, who are approaching us because they suddenly realize the power of simulation, not just to design some product, but to educate people. And for example, I was discussing with HSE, is a health safety executive in UK. They were very interested to use this kind of modeling to define different kind of scenario in order to protect the medical staff. Should they wear some mask? Should they wear some shield? What is the position for that? Can we analyze the different drop the position depending upon the HVAC and environment in such a way that they will minimize the impact? For example, another example that we have online is that many people don't want to close the nasal clip because it's painful. If you wear that for several hours, you will see the mark over there. But when you show that if you do not close the nasal clip, you will increase the risk of contamination by a factor of 10. Wow. But these people will say, okay, I will close it. Even if it is painful, I'm more interested by staying healthy. So we are just using that to illustrate what's going on.
Very, very good point. It's we've spent our whole careers using simulation to answer design questions, right? How do I optimize the performance of this device, or how do I keep it from failing, or increase the whatever parameter I'm trying to do? And we're seeing how it can be used as an educational tool outside of engineering to help people understand what's really going on, rather than kind of, like you say, taking it for granted because the rule's there. I think it's fantastic. And are we starting to see people look at simulating? You mentioned in the hospital environment, but using simulation to figure out how we can set up restaurants or office spaces and keep what's the proper rules for social distancing as we kind of slowly ramp up? Is that something people are starting to look at?
Well, from my end in Europe, and then I will let Marc explain, is that we are getting out of lockdown very soon. And therefore, I'm receiving several requests from people having some sports center to say, okay, can you explain me what's going on? Can I restart safely? I've got several questions. I've got my daughter at school, and we are planning to restart school in a couple of weeks from now. But there are some rules saying that, okay, no more than 10 kids per a classroom. There should be some distance over there. People are saying, okay, no, I don't want to send my children over there. And therefore, we have this kind of request, which, okay, can we model that and bring some answer rather than having this kind of ongoing polemic? So there are some discussion taking place like that, and people are approaching us. And Marc, I think that you've got something to add.
Sure. Yeah, so I don't know that we've seen an increase in the discussion yet. At least I haven't been personally involved in those. But I will tell you that, one example that has circulated some on the internet is the example of a restaurant. I believe it was in Wuhan, where they were doing the tracking of the COVID virus. And they found, they showed this really interesting map that showed here's a group of infected people that sat right next to a ventilation vent in the restaurant. And then they showed when the people downstream of those people at the time they're in the restaurant were infected by the coronavirus. And it was very clear the importance of the HVAC system and what we could do to better design those systems. But then what we also have to do, like what Thierry's mentioning, to protect ourselves by being aware of the surroundings and, what we're exposing ourselves to when we go out to eat. So I think it's going to be something that becomes very important very quickly if we want to get back to business as usual.
Yeah, because I saw that Texas's rules are basically 25% occupancy, kind of this arbitrary number. And of course, I was going, where's the simulation? Where's the test data? Why 25%? Shouldn't it be more density based? There should be more science behind that. So I'd love to see that. And hopefully we'll start seeing some simulations done to help us understand that. You touched on it briefly, but I want to go back to how did Ansys really get involved in this response initially? I think customers kind of automatically started using the tools, but Ansys as a company, I think Ajay kind of kicked some things off early on, right?
That's correct. But not just Ajay. Ajay is very passionate about healthcare. But spontaneously, Marc, myself, and a few others, we've been driving the healthcare activity. Well, we've been saying for years that this in-situ approach, using computer model for healthcare, is a way to accelerate medical innovation. Well, we have a perfect example here where time matters more than for anything else. So it was obvious that we need to go over there. And suddenly, I've got several of our existing partners, whether they are academic or industrial people, whether they're coming from the healthcare industry, but some of them from the consumer product industry, even from the automotive industry, saying, okay, how can we help? I've got many people coming to me to say, okay, we are using simulation, how can we help? And suddenly, this is the way to tell them, okay, here is what we are doing, here is how we validate. Validation is extremely important. So we set up this kind of first website like ansys.com/COVID in order to illustrate different ongoing collaboration that either we did at Ansys or that we were doing with a partner. And since then, we keep adding to them. Some people coming to us, some of them are confidential, others are not, but to show what could be done. And now that's the kind of call that I would have is that we're just scratching the surface. There are many scenarios that we can consider. What's going on in the subway? What's going on in the airplane, in the train, in the car? Can we understand that? Put some real quantification of that, just like you were mentioning. We cannot do all that by yourself. So any kind of help would be very welcome, including some funding from the government so that we can assist quantify this element.
It's a great examples. Yeah, I think, we appreciate it. I think, everybody's looking for ways to help, and Ansys had the right tool set at the right time and I think even more so, the right people. The global Ansys network is a very powerful tool in and of itself. Customers and academic partners and Ansys employees and channel partners, quite an impressive group of people. So we're going to kind of wrap it up here. Is there anything else either of you want to add that you think our listeners should know about the Ansys response or the tools being used?
From my side, I think we covered most of it. Yeah, I think it was a great discussion.
Good.
Well, if I can add just one point,
sure.
Just one double recommendation. I would ask everybody to be humble and to be proud. To be humble because we are not part of the medical staff, and therefore we cannot say that we can counter the propagation. But at the same time, as we were explaining, to be proud, we have a tool that most people don't know about, and we need to talk about that. We need to use this tool because the medical staff alone will not be able to do that, and they fully recognize that. So we need to all be humble and proud for that, and we will be fighting this virus.
Mm-hmm. Yeah, be an advocate for the use of simulation in this case, for sure. Yeah. So if listeners want to learn more about what Ansys is doing, where should they go? Well,
there is a site, ansys.com/COVID, COVID, and that's where we are storing some information. They can always contact us as well if they are willing to provide some help. We welcome any people, especially those who are trained in Ansys. We can certainly make sure that they can work, and we are ready to help as well.
Great. Fantastic. I really appreciate fantastic discussion. I could go on and on and on, but I think we covered the basics. And do check out that website to learn more. And if you're doing work using simulation to respond to the COVID-19 pandemic, do reach out to the contact information on that page, and please share and cooperate. And together we can, in a global response, can do a much better job. I'll mention also, we've done a couple other podcasts and seminars on using Ansys Cloud and other HPC resources. Don't forget that. Speed is of the essence. So please don't forget our HPC capabilities as well as all the tools as a way to get faster answers better, regardless of the tool set you're using. So guys, I really appreciate the chance to virtually talk with both of you. Hopefully we'll see you again in January at the sales kickoff, and hopefully we'll be able to get together again. But if not, we'll see you virtually in the coming year. I really appreciate it. Thanks.
Thank you.
Thank you, Eric. Great discussion. Yep. Bye-bye.
Bye. So I don't know about you, but I think that's really cool, everything they talked about, and we could have gone on and on. If you have any work you've done that is COVID-19 related, please reach out to either of them or to us at podcast@padtinc.com or even info@padtinc.com, and we can connect you with them. I think the community would benefit from even more examples. It's a great way for us to show people outside of the simulation world what we do for a living and to really make a difference in answering some of these questions that people have. I read someone who's a bit of a skeptic sent me an article about, this type of mask doesn't work. And I'm like, well, it doesn't work in certain ways because, and I showed them the simulation of someone coughing behind the mask and how, if the mask isn't tight, how the particles get out. And it kind of explained the results they were seeing in the article. So it was really useful to deploy in that area. So it's commercial time. Please consider PADT as your Ansys supplier if you are in the southwestern U.S. and for simulation consulting and customization, no matter where you are. We are also just as good at additive manufacturing and product development, so give us a try. We love what we do, and our customers tell us we are good at it. These times are difficult, and you may be facing some challenges you never expected. We're here to help. We have not slowed down, and we can assist with simulation, customization, product development, testing, scanning, 3D printing. Whatever you need, please do reach out. If we can't help you, we probably know somebody that does. So we'll get through this together. In the world of news, let's talk about the Ansys stock. It's almost at the exact same place it was when we last checked 2 weeks ago. It closed Friday at $253.93. So that'll be the 15th, Friday the 15th. And that's year-to-date down only 1.18%. So you're in the noise level. So not a bad place to keep your money in the middle of all this. The S&P 500 has gone down 11.47% since the beginning of the year as a point of reference. They did release their Q1 numbers on May 6th. So we just missed that last time I recorded. So let's talk about that. It's tough out there. So it's the first time the numbers haven't really gone up. It was kind of interesting to see. It wasn't bad, but we've had such a string of big numbers that it was kind of a surprise to see. But all good news. One thing to point out before we get started is Ansys, at least new to me, has a new way of sharing their quarterly data. If you go to ansys.com and then click on the About Ansys in the menu, then click Investor Relations under that, you'll go to the Investor Relations page and scroll down a little bit, and you'll find a block called Quarterly Results. And they've got the press release, they've got remarks, the webcast, presentations, and even an infographic that I thought was pretty useful that has the key numbers in it. So even more ways to get info. And if you really care about Ansys, I recommend every once in a while you listen in on one of those investor calls and just hear how Ajay and Maria and other executives, how competent they are. I'm always impressed by their answers. So do check it out. It's important to kind of get a feel for what they're thinking, and that's a good way to get a judge of that. So the numbers, Q1 revenue was $305 million versus $317 million last year for Q1. That's down only 4%. Profit was $46 million, down 47% from Q1 last year. So they did spend more money with just a small change in a small change in revenue, but expenses went up. So there you go. The good news is, and why no one should panic, and I think why the stock is doing so well, is they have $718 million in cash sitting in the bank. So they can ride this out for quite some time. They are also using a metric. I think I mentioned this the last couple times, but it's becoming more prominent in their discussions. They call it the annual contract value. And because they have so many different apples and oranges to compare and where is revenue coming from, they just kind of look at, okay, if something was executed in the given quarter, so let's say we're talking about quarterly results, the annual value of that contract rather than the quarterly value of that contract, or if it's a multi-year contract, the multi-year value. We're just gonna record what that is worth to what kind of income that's going to bring into the company during the next year. So I think it's a nice metric. It was $301 million, by the way, and it was $305 million for the first quarter last year. So I think that's a good indication. We did also learn, this may have come out somewhere else, but I noticed it for the first time in the press release for the quarterly results, that when Ansys purchased Lumerical, that was the last acquisition they did, they paid $107 million for that. It's an optical simulation tool. So in general, from a stock standpoint, considering what's going on, not bad at all, especially if you consider also the amount of business that Ansys does in Asia and Europe. So we tend to think of it really hitting economically in the U.S. kind of starting March, maybe, the end of Q1. But for Asia and Europe, it of course hit much earlier. So I think that's what we're seeing here, and very strong considering everything that's going on. So we'll keep watching that. Look forward to Q2 and then on and on through the end of the year. There is no other Ansys news to report. They got some certifications from some other companies that use their electronic simulation tools, and those need to be certified for use. And we don't have any PADT news to share as well. So in the world of the Ansys blog, on the topic of today's interview, they actually published a blog article about something we talked about with Thierry and Marc was, can ultraviolet light disinfection solve the PPE shortage? So people are using light simulation tools from Ansys to see if we can get in there and clean these PPE. So that's a good article worth reading. I won't tell you what the conclusion is. Also, just in time, because everybody needed to go home and didn't have access to their desktop computer maybe, Ansys has introduced a web-based, what they call virtual desktop infrastructure, and it runs in the Ansys cloud. They've also made Ansys licensing flexible for the Ansys cloud, so it's even easier to run in the cloud. There's a little bit of details there, so I'm not going to get into them. Please do read the article. It's actually called Introducing VDI Flexible Licensing on Ansys Cloud. It's brand new. We'll get Sina to take a look at it and maybe get some input from him on how well it works. And again, making it easier for you guys to work from home. The third article that I'm pointing out in the Ansys blog is called Keys to Effective Communication in the Virtual World. And we've been going through this, as has Ansys, and they're kind of pros at it, right? Because Ansys is truly a global organization. They are spread out everywhere. So they're used to working in a virtual world. So I think it's some really useful information. They got 3 different leaders, one from the US, one from Europe, and one from India. I think one is in sales, one is in training, and one is in technical support. So they all give different perspectives on using the virtual meetings and email and all sorts of other things to stay connected and how to be more effective using these new tools. Well, not new tools, especially not to Ansys, but tools that everybody's using now. On the PADT blog, I have to make a public apology. Ahmed did a fantastic job of writing up a blog many weeks ago on the new licensing in Ansys, and I completely spaced on posting it. It's up there now. Why this is a big deal and why it should have gone up as soon as he got it finished is years and years ago, Ansys started using a modified version of the FlexLM license manager. FlexLM is the company that kind of owns shared licensing, right? Where you've got a server that says you get 5 seats and people can check out how many ever seats they want. Ansys modified that tool to give a little bit more flexibility, especially in Workbench, to users so they could do multiple things at one time and not check out 2 licenses. It's really complicated why they did it, but it made sense at the time. The problem was most engineering software packages that use FlexLM right out of the box, and Ansys was different. So in larger companies that had a lot of different software, it was a bit of a problem with the IT department sometimes installing the Ansys License Manager, and we needed to update it every release, and it may have been different than what they were using for other tools, blah, blah, blah. Well, that's no longer an issue. They've gone back to the standard FlexLM. They've done what they need to do inside the core of the code to allow that. So in the world of IT, for people who support Ansys, there is much rejoicing. There's only one port to open, and also you can use the same license manager for all your tools, not just Ansys tools. So do check it out. Ahmed's got a really cool article about it. He goes through the details, why it's important, why we care, what to do, and he's also got some really cool pictures of surprise groundhogs to spice it up, which I thought was pretty funny. Upcoming events. We've got one webinar scheduled for this month remaining. We already had one earlier in the month. It's really a cool one. I'm really looking forward to this one because I love this topic. It's called Designing Better Rocket Engines with Ansys. And so we're going to talk to one of PADT's customers that is using Ansys to design rocket engines. And we're going to find out from them what they're learning and what they know. So very cool. It's going to be this coming Wednesday, 5/21 at 11 Pacific. And if you missed it, of course, you can always go to Bright Talk and listen to the recording. We also had, if you like the discussion we had today on this podcast, we had a panel online on Bright Talk as well, where we discussed using 3D printing to deal with COVID-19. And it was a fantastic discussion. It was 2 universities and 2 companies, all Ansys customers, including Ansys, Arizona State University, University of Colorado, and I always get the 2 confused, and L3 Harris. And we had a really good discussion about everybody's doing something a little bit different and the challenges they faced and they overcame, and just the fantastic way the community came together to get tools into the hands of the right people as quickly as possible using 3D printing. So that's available on Bright Talk as well. So all of our webinars and seminars are available on www.brighttalk.com. If you search for PADT, you will find all of them, and you can listen to the old ones and register for new ones. The big Ansys event, of course, that's coming up is Simulation World. That's June 10th and 11th. So register if you have not. It is free. Hopefully some of you have submitted papers to be presented. They are gathering all those together and coming up with a full agenda right now. So in conclusion, I want to thank you. I want to remind you to don't forget to subscribe to PADT's emails at padtinc.com/opt-in. Spread the word about the podcast and let people know about it, and hopefully get more subscribers. And don't hesitate to reach out. And in conclusion, at PADT, since this whole thing started with the coronavirus, we started using the saying, stay safe and healthy, then productive. That was kind of the priority, is do safe things, keep yourself healthy, then worry about being productive. And that's worked really well for us. We've been very productive. We've been safe and everybody's been healthy. But as states start to open up and we get out there in the big bad world, we're realizing that the people may not be doing the safest thing around us. They may not be healthy. So we can't change the behavior of those other people. We can rant all we want on social media, but we ain't going to change them. So we have to stay informed and make intelligent choices. We have to be the adults in the room sometimes. So we've changed our saying to stay smart, safe, and healthy, and then productive. So be smart out there, and we hope to see you in the next podcast. Thank you for joining us for the All Things Ansys podcast, episode 63. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.